Hello everyone. In this video, I would like to just record the board and how to solve the problem. I try to use my cell phone today. Some people told me that using the cell phone may be a better idea. Now I try it, right? Maybe I still prefer like so teaching like face by face. At least we can have some kind of social communication. But anyway, let me try today. I would use a different variety way of teaching to serve you. Okay, so let's read the question. A bacteria culture starts with 1,000 bacteria after 2 hours. The estimated count is 10,000 bacteria. First question, find the number of bacteria after 3 hours. Second question, find the numbers after 5 hours. Third question, find the rate of growth after 5 hours. And question D, when will the population reaches 15,000 bacteria? Okay, so let's see how we deal with this. Now I copy the formula. We talk about the function f of t equal p0 e to the rt before in the previous video. So this is the formula for exponential function. So I'm not going to explain anymore because I had mentioned about this formula before. So just a quick review. A is the amount, the same like f of t, respect to time, right? So A is the amount after, and P0 is the amount at the beginning. E is just natural log number, R is the rate of change, and T is the time. So to solve this equation, you have to substitute on the number you know in the equation and solve for the unknown number, right? Unknown letter. So usually if we have one equation, the only way we can solve it is one unknown left over. The rest of information have to be filled to be able to solve for one unknown equation. If you have two unknown, you should have two equations so that you can solve for it, right? So let's try to substitute anything we know. Now we know A is the amount after. P0 is the amount at the beginning, the principal amount, the original amount. So do we know about A? And if you look at the question again, it says after 2 hours, the estimated count is 10,000 bacteria. So yes, we know A. A equals 10,000. So A is the amount of bacteria row after 2 hours. P0 is 1,000 at the beginning, right? At the beginning. T we know, which is 2 hours. The only thing unknown is R. So I substitute the T by R, T by 2. So I put in front, right? So now this equation have one unknown now, which is the rate, the R. We want to find out the R. So how do we solve this equation? First of all, let me divide both sides by 1,000, right? So if I divide this by 1,000, actually I'm missing the E here. It should be E to the 2R here. So if I divide, this is gone. 1 0 gone, 1 0 gone. This gone, this gone, gone, gone. So I have 10 equal E to the 2R. So now I can solve this equation by taking ln both sides. So ln 10 equal 2R, I'm going to bring it down, ln E, because that's how we apply the rule of power, of the power, logarithmic power. We can bring it in front. But what is ln E? If you can calculate ln E equals 0. Equal 1. So this is like 1, right? So it doesn't matter. So it's gone. It's 1 times 2r, it's just 2r. So now we have to solve for, we have ln 10 equal 2r, divide both sides by 2. We got r equal ln 10 over 2. So r equal ln 10 over 2. Okay. Now, it say the first question asks find the numbers after 5 hours. No, after t hours, right? Question A, find the number of bacteria after t hours. So what they want you to do is they want you to establish a general formula to answer question A, because they didn't say how many hours. They just say after t hours. So if we don't know the time, we're not going to find the real number, but we will establish a general equation. So to answer question A, what you do is say the amount after t hour will be A equal the same equation 1000 for the P0 and E to RT. So we have E. Now we know R equal ln 10 over 2. So we can say ln 10 over 2 times T. And because of T hours, we don't know how many, right? So we just leave it. So that's how you answer question A. And I'm going to show you the question, to show you the answer on the top, right? So that's how it is. So A equal, the amount equal 1000, E ln 10 over 2 times with T. Now we're going to answer question B. Find the numbers after 5 hours. So to solve B, we just have to substitute into this equation. 1000, A equal 1000 E ln 10 over 2 times with 5, right? Yes. So now you will find out after you plug in the calculator. And I don't have somebody help me to record, so I'm gonna have to put down the cell phone and get the answer and show you. So the answer will be e to the power ln 10 divided by 2 times 5. Let's see. Actually, I can do like this as well. So I'm going to say 1000 e to the ln 10 to the power 5 divided by 2 with 2.5. Okay. Now, because why I do like this? Because I know e to the ln 10, this, if you can calculator, for sure e to ln 10 equals 10. So we can do 1000 times 10 to the power 2.5 and see how much you get. So that is the equation. So we're going to do 10 to power 2.5 times with 1000. The answer is 316 to 28 round off to 28 bacteria. That's the answer. Okay, so that's how we answer B question. Now I'm going to answer the C question. So how do we find C? Find the rate of growth after 5 hours. Now usually when they ask for the rate of growth, it means we have to find derivative, right? We're going to find the derivative of A, so it becomes A prime or dy over dx, remember? So in here we're going to say A prime, but let's write out the original equation first. We have 1000 e to the ln 10 over 2 times with t. Find the rate of growth after 5 hours. So A prime will be equal 1000, just 1000. E to the, remember yesterday we're talking about e to the x, derivative e to the x is e to the x itself, right? So noting chain will be e ln 10 over 2 times t. But remember, if you have the derivative inner function, right? So here is the inner function, right? If I put in the square bracket, so this is ln 10 over 2 is just the number itself, and derivative ln 10 over 2t is just ln 10 over 2, same thing, right? Okay, so now so a prime equal that. So our function is ln 10 over 2t. So derivative of this is this. Okay. So now we substitute in, we find the rate of growth is 1000 e to the ln 10 over 2 time with t is 5 hours because that's what they asked for. Time with ln 10 over 2. And let's see what it will become. So I'm going to say I go backward, right? I do the exponent first. So I key in e to the power, okay, I don't know if you can see my calculator. E to the power, e to the power ln 10, e to the power ln 10 time with 2.5. 5 divided by 2 is 2.5. Time the 2.5. And enter. And time with ln 10 divided by 2 again. And time with 1000. Okay, let me try it again. I probably make some mistake. So second e to the power, I'm going to say power ln 10 time with 2.5. Enter. With time with ln 10 divided by 2 time with 1000. So the answer is 364. 364. So the rate of change at that after 5 hours is 364, 0.71 bacteria. So that is the rate of change after 5 hours. So that's his answer for question C. Now question D is we have to solve for the time. When will the population reach 15,000? So when will the population reach 15,000? I'm going to have to erase some of the bar here. Maybe let me erase this part and try to solve the last question. Okay, so the last question is question D. And the last question says, when will the population reach 15,000? So I'm going to substitute A by 15,000, right? and we want to solve for t. So what is our equation? Our equation is 1000 e to the power ln 10 over 2 t times t, right? That's the original one after we developed the formula. So now we're going to solve for t. And again, I'm going to divide both sides by 1000 first. So cancel, 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 cancel. So I have 15 equal e to the ln 10 over 2 times t. So ln, take ln both sides, ln 15 will be ln 10 over 2 times with e, ln 10 over 2 times t, bring it down, right, time with e. Sorry, ln e. But ln e equal 1. So to solve for t will be ln 15 divided by ln 10 over 2, right? This divided by this. So cancel that. So that will be equal to t. So that's how we solve the equation, right? Okay, let's see how many years t is equal. Sorry, how many hours. So ln 15, you can use a calculator for this. Enter, divide by, open bracket, ln 10, divide by 2. So it's about 2.35. So t equal 2.35 hours. That's the answer. So that's how we solve for t for question D. So I hope that you will be able to follow this. Sorry for my hand. I have to use the cell phone and record it. So it may be a little bit shaking or something like that. I will check the quality, and if it's so bad, I have to record this lesson again. But I hope that you will be able to follow my handwriting and my explanation. So I'm going to show you again the bar for question A, question B and C. How do we solve it, right? And the last question D is here. We substitute the amount of 15,000 equal original question is 1,000 e to the power ln 10 divided by 2 times t, because we find out the R rate. Now we solve the equation. We divide both sides by 1,000. We got 15 equal e to the power ln 10 divided by 2 times t on the top. So now what you have to do is take ln both sides, ln 15 equal, bring down the power ln 10 divided by 2 times t in front of ln e, and ln e is just equal 1. So now you have on the number, ln 10 divided by 2 is just a number. And on what you do is your ln 15 is a number divided by ln 10 over 2 to solve for t. And you get the answer is t equal 2.35 hours, if I don't make any mistake from my calculator. Okay, so that's how you solve this application of the derivative of the exponential function. I hope you follow along with it, and I will give you maybe another question from this application, and we will end at chapter 7, and that is the final lesson in our course. I will provide you on the lecture notes some kind of sample solution in our course. some solution will show you step by step how to solve it. Now, any exercise I give you, I will not show the solution step by step, but I provide you the answer key. So if you try and you did something wrong, if not like matching with the answer key, you can try it again and figure it out, and or email me and ask me if you enroll in my course. I am going to end the lesson now, and I think I will give you another 1 or 2 video lecture like this, and we will end the whole introduction to calculus course. I will upload some kind of quiz, short quiz, and one final unit test, so that you make sure that you understand the course and capable of writing the test, to learn the first course, introduction to calculus, and it's very useful for your continued academic journey. So good luck and bye for now, and I will see you in the next video, maybe another application of logarithmic derivative, logarithmic function. So bye for now. I hope you enjoy. You're not seeing my face today. I just try to record by the cell phone. So hope that you follow along with it, and maybe this is better qualification. Bye for now.